Hi everyone. Thank you for joining us for this webinar on the use of curated pronunciation data in text-to-speech models. My name is Holly Dann, and I'm a pronunciation lexicographer with Oxford Languages. And today I'm going to be moderating this panel discussion between our guests who are joining me today, Rhyan Johnson, who is a machine learning product manager and staff data engineer with WellSaid Labs, and my colleague, Dr. Catherine Sangster, who is an Oxford Languages executive editor of pronunciations. So before we get started, and I'm going to ask them to introduce themselves a bit further, I just need to go through some quick kind of housekeeping points with you. So first of all, please note that this session is being recorded, including the Q&A time. And after introductions, I'm going to be facilitating this discussion about the kind of work that we do at our kind of respective companies and how we've collaborated in that work. And then we'll have time, like I said, for a live Q&A afterwards. So please submit your questions in the Q&A tab on the right-hand side of the screen that you should be able to see. And you can send questions at any time during the discussion, and they'll be addressed in the Q&A time at the end if we have time. So you can also vote on the questions if you see them pop up, if someone's asked a question that you're interested in being answered. So feel free to vote whenever you see anything come up, and I encourage you to do so, but that doesn't necessarily guarantee they'll be answered because we probably won't have time to address everything, so I'll just pick a couple of questions. You can also use the chat tab, which you should also be able to see on the right, to interact with other audience members and also to flag up any technical issues. And my colleagues are also here who will be able to do their best to help you. And finally, please bear with us if there are any technical hiccups. Hopefully there won't be, but if there are, we'll get them sorted as quick as possible. So let's get started. So my first question is to Rhyan. If you could tell us a bit about yourself, your role and your work, please.
Thank you, Holly. I'm happy to be here. I'm a product manager and staff data engineer at WellSaid Labs. So as a data engineer, I get to develop lots of different features from our text-to-speech technology, which we get to talk about today. And as a product manager, I'm really just responsible for understanding what the industry needs within text-to-speech and how our machine learning team can build those solutions. And it's really fun.
Great, thank you. And Catherine, same question. Could you tell us a bit about yourself, please?
I am an executive editor at Oxford Languages. I'm the functional lead for pronunciations, which effectively means that I look after, with my team, I look after the pronunciations that appear in Oxford Languages dictionaries and in our data sets. So researching the ways that the pronunciations would be transcribed and overseeing the creation of audio to reflect those pronunciations as well. So my background for this work is sort of sociolinguistics and sociophonetics, but I've been doing this for some time now. That's where I am.
Great, thank you. Rhyan, then, could you tell us a little bit more about WellSaid Labs, kind of explain what the company does, please?
Yes, I'd love to. WellSaid Labs is a leading AI voice company for enterprise and professional applications. So we offer text-to-speech products and services in our studio space as well as over the API. Our text-to-speech technology is built on proprietary data that we curate. We're very careful. We take responsible AI very seriously. So we partner with our voice actors. We build our technology in-house. So we have a lot of control over what's being built, what's being trained, and what features we can offer our customers. Our customers are primarily in the learning and development or educational spaces, so it's really important to us that our voices are clear, ultra-realistic, true to the training data, and don't hiccup while they're speaking because listeners are trying to absorb really important content from these voices. I think that's it.
Great, thank you. Catherine, could you tell us a little bit about Oxford Languages more generally, please?
Yeah. So Oxford Languages is part of Oxford University Press, which publishes the Oxford English Dictionary and many other things. Oxford Languages works on providing digital languages data in all its many forms. So we have a large number of colleagues who are our language data specialists, and they build lexical data sets, text and speech data sets, which have lots of uses, have lots of applications, but one of the thing that's particularly pertinent to what we're discussing today is their suitability for model training and for other natural language processing applications. But because we're working in a setting that's providing editorial content for dictionaries and those data sets, we kind of doing that work in parallel with making those data sets available for licensees and for partners such as WellSaid Labs, that we can, so that the data that we're already putting together can be put to new and different uses, which is, it's really exciting. And I didn't say before, it's really nice to have this conversation and have it be able to share it as well. So I work in the pronunciation team, like I say, and our focuses are things like so we make audio, we transcribe, we have different ways of transcribing. So we use the symbols of the International Phonetic Alphabet in different ways, and I'm going to dive into that a little bit more further into our webinar today. But we also have the possibility of other transcriptions, simple text respelling that we use, that we can make available as well. Sometimes IPA transcription isn't what the end user requires, isn't what the user story is best suited for. We're getting very much involved more with localization. Initially, our dictionaries focused on British English and North American English, but we have we're building out what we have to offer in Australian English, Indian English, and a range of other Englishes as well. So yeah, the coverage is very wide and growing, and sort of underpinned by the lexicographical work that we do. And because that lexicographical background, the updates are happening constantly. So we've got a really good foundation of, what's new, what's the priority, to keep the data set big and growing, and growing in the right direction. Yeah, I think that's pretty much what I wanted to say there.
Great, thank you. So you've both of you use pronunciations in different ways, but you have kind of a slightly different approach to it. So Ryan, would you be able to tell us a little bit more about the sort of text-to-speech point of view in pronunciations?
Definitely. And I realized I was starting to get into this just describing what our technology is and who most of our users or audience are, but pronunciation is hugely important as people find ways to take advantage of generative AI and utilize text-to-speech instead of maybe human voice recordings to save time and save money and all sorts of other things, really scale up the content that and the audience they're trying to reach. We don't want listeners to be disengaged or pulled away from the content they're trying to absorb. So anytime a text-to-speech voice results, mispronounces something or hiccups in some sort of way, you're really taken out of the content you're trying to learn. So pronunciation is only a component of that. There are other factors that contribute to the naturalness of a synthetic voice. But we're here to talk about pronunciation, and I want to highlight the fact that our avatars cover lots of different speaking styles, delivery styles, dialects, languages. And if you're trying to create content for all of these different audiences, being able to rely on avatars and trust that their delivery is going to be accurate is, of course, hugely important. So we're working all the time on the machine learning team to not only extend the model's capability of learning accurate pronunciation the first time, but when pronunciation becomes ambiguous, just like it does with humans, there are words we don't always know how to say, words that get invented, like new medicines, new brand names, human names, or just even regionally, what the preference might be between saying aunt or aunt. That's a common one in America. It's helpful to be able to craft those kinds of things particular to your audience. So that's where pronunciation tools go beyond just text-to-speech ability to pronounce accurately. How can a user actually shape those things? And that becomes really important for WellSaid.
Thanks. Catherine, so Oxford Languages obviously comes to pronunciations from a slightly different perspective, and it's all rooted in lexicography. Would you be able to tell us a little bit more about, I suppose, what lexicography is to start with, people who are unfamiliar?
Yeah.
But also,
Of course. Thank you. Yeah, so lexicography is the making of dictionaries, and our history is in exactly that, is in creation of dictionaries. And so pronunciations, as with Ryan's work, the pronunciations are only a small part of that. We've got the the definitions and the etymologies and the quotations and all the rest of it. But for the pronunciations, it's the part where it says this is how this is pronounced. And you would have a written form, a transcription of some kind, which would guide you towards a pronunciation, which would be informed by your own accent and your own way of speaking. But also we have for about 10 years or more provided in the Oxford English Dictionary, for instance, audio, so that somebody can look up a word and not just read the pronunciation, but also hear it spoken by an actual person saying it. And that kind of variety coverage adds up something that's the focus is a bit different when you're thinking about a use like WellSaid Labs make of it. So we would, for a dictionary's purpose, you might just say, well, we want, for a smaller data set, you might say, we just want one pronunciation. We just want, one that's not wrong, and we'll say it that way. But for a larger dictionary, you probably want to have wider coverage, more variants. And by variants, I mean not just like regional differences, but also things like scone, scone in British English, cot, court words in American English, those sort of things where actually they're quite big systematic differences, and they make a difference to the pronunciation, to how you transcribe it, and of course to how you'd hear it. So broadening that coverage out and saying, we're not just going to have illustrative examples of things, we're going to have something more comprehensive. We can build out our data sets to support that kind of use. And the alignment that we have with the corpus work, the big data that our colleagues, our lexicography colleagues work with, really gives us very good guidance on what to include, on what language changes are underway. So we've got a lot of access to those editorial specialists and to subject matter experts. So if it is like a medical application, like you were in your example, that would be something that would be well placed to know what the new drugs were, look at how, and how would we research them. Another thing that's probably worth sort of saying is, people sometimes ask us, how do you know how something is pronounced anyway if it's new? And that's something that we're doing all day, every day, when new words are being added to our data sets and to our dictionaries. A lot of the work that Holly and I are engaged in day to day is, well, how is this pronounced? We'll go and we'll look at video evidence, we'll speak to people, we'll consult experts, and we'll figure out, this 17-syllable drug name is stressed on these syllables, and that's a hard G, not a soft G, and those kind of things. We'll figure them out, we'll put them into our data sets, and then that's available not only for the dictionary end users, but for the licensing end users as well. So yeah, that's and the last thing I want to say on that point is the audio that we make as well. It's we start with the transcription, and then when we make the audio, this is something people don't always recognize, is that they're not reading a word list, they're reading a transcription. So we've already checked how it's pronounced. When we make the audio, the pronunciation, that the audio is informed by the actual phonetics of the pronunciation, which means it's really nice quality, and it's really close, very accurately linked with the transcription that it's paired up with in the data.
Yeah, thank you. So I'll ask you a little bit more about the specifics of kind of how we create pronunciations and what they look like, and how we create the transcriptions in a minute. But first of all, I wanted to ask Ryan if she could give us a little bit more of an explanation of the text-to-speech technology behind WellSaid Labs and how it works.
Yes, I'd love to. I'm just going to pop some slides on the screen for us. This is one of my favorite things to talk about, so forgive me if if I talk too long. Just interrupt if I'm going too long. I'm going to talk at a high level too, just generally around text-to-speech technology, not necessarily all of the secret sauce that makes WellSaid voices perform as well as they do. But all of this leads into, eventually why we chose to partner with Oxford and how important it is that this partnership helps us deliver not only these high quality voices, but high quality features for our customers as well. So let's talk about how text-to-speech even works. How does a computer receive audio and text and learn how to then receive text and create audio, right? We start with something called a spectrogram. It's really a multi-dimensional view of sound. So the audio files that the model is going to train on get kind of exploded into all of these dimensions. So you can see that sort of rainbow image there. Across time and the various frequencies that are at play when we're speaking all come at different loudnesses and overlap. And so it's really important if you're capturing a voice that as many of those dimensions are learned at the same time. Everyone has a vocal ID. And if we're training on human data and we want that synthetic avatar to sound as close to the original training data as possible, of course, understanding everything that makes up a human voice and how our human ears hear those things is really important. So we start with a spectrogram. I've said in past presentations that a fun fact is there are folks in the world who can actually look at a spectrogram and read it. And in rehearsing this material, I learned that Catherine is one of those people. So it's a neat, it's a very cool representation of speech. And I'll also add that it's really important when you're training on speech data that the audio files are very, very clean and the background noise isn't also represented here, because the model, of course, is going to learn that whole like acoustic landscape. So isolating to what makes the part of audio speech is really important. We can, as humans, detect background noise and differentiate what matters to understand language and what doesn't. But we try to keep that as clean as possible, give the computer as much of a leg up as possible to learn those things. We then create something we call an alignment. Oh, you know that the voice actor read from a script, and we know that they read these words that sound like this and look like this in a spectrogram, but what does that mean? We use speech-to-text technology, the reverse, to help timestamp exactly where in the audio file a certain word started and ended, certain specific sounds started and ended, right? And we start to get closer and closer to recognizing all of the sounds that make up this phrase start to record the voice. You can see visually on the spectrogram above. And if we can actually draw that connection, now the model understands that if I see these various frequencies lasting this amount of time and overlapping together in this way, that's going to always sound like an S sound, right, in the audio. So that's how we align the text and the speech together. From there, there's our little voice actor who gave us a script and audio. There's the alignments getting built so we can understand exactly how these sounds line up to the audio files. And the very oversimplified high level, the model is told to go, and it will make many, many guesses. Every time it makes a guess, let's say it gets a new bit of text it hasn't seen before, it takes a guess as to what that spectrogram should look like. It can measure that spectrogram against the real audio, recognize some of the differences there, adjust its rule set so the next time it gets text, it can make a better guess. And it just does this a million times over. There's many, many other parameters involved. There's many important components to pronunciation, intonation, everything that makes up one particular speaker's voice compared to a different speaker's voice. All of those things are at play, but at a high level, that's the concept, right? It can take a guess, see how close it was. Does the spectrogram match or not match? Where are the differences? And then adjust its rules as needed. And in the end, we get this nice audio wave file so that when we deploy a model, something that we release to our customers, if they provide new text, then the model can make a guess that we believe is stable, has predicted accurately what that text should sound like for that particular speaker. So an example of this, I actually have a couple of audio files here. We'll start listening to a recording from our voice actor, and then we'll hear how well the model synthesized that actor's voice when given brand new text it didn't record from. So let's hear the first human recording.
Here's what's in this for you in the first chapter. If you ever find yourself playing a trivia game about liquid penetrant testing, you are definitely going to win, because we're going to see how PT got from where it started to what it has become today. I'm being told that I am in fact old, proved by the fact that no one plays trivia games anymore. Ouch.
This particular voice is a voice used to narrate learning content for, really dense content, honestly. The audience is learning a lot of stuff around, even in the verbiage here, liquid penetrant testing. It's lots of just dense things. And so to stress test it, we were also testing our verbalization layer. So the text I'm about to play, we're testing new vocabulary that's in the same domain, let's say, that this voice was trained for, but it's also trying to verbalize a lot of numbers and measurements and things like that. So now let's hear how the synthetic voice sounds.
Today is July 18th, 2024. And now for question number 1. Are solvent suspendable developers applied by brushing or spraying? Question number 2. True or false? The threshold of visual acuity for a person with 20/20 vision is about 0.3 inches.
I'm particularly proud of this voice. I think we did a really nice job of replicating the original voice actor, and working with this actor in particular. It was very special to learn that content he had been developing on his own for a long time needed to play nicely with now content he could scale up using his synthetic avatar. And in fact, listeners had no idea if they were listening to his human voice or his synthetic voice. All of the media, it just played really well together and became a collection of like a whole curriculum that he could teach more and more people with. So I want to talk about 2 different approaches now within those alignments. There are graphemic and phonemic approaches in text-to-speech. A graphemic approach is going to stick with all of the script as written. We're going to work in English today to really illustrate this. And English is kind of tricky. If a script is provided in English and we try to align all of those sounds to the exact, alphabetic characters that we're used to spell those words, we're going to get an alignment sort of like this. We see the word apple. We try to align each character to a snippet of the audio. And it's tricky here in a graphemic approach because apple is a simple word. But when you look more closely, it's a confusing word. We have 2 P's, even though we only say one of those sounds. We have a silent E at the end. And what's not written is a small vowel sound between the P and the L. And if you're trying to align human speech to some sort of symbology, English spelling makes that a bit difficult with lots and lots and lots of data, similar to how all of us learned English, learned to speak and, memorize words and spelling and all of those things, learning all of the exceptions to the spelling rules, etc. A machine can do this, definitely. A graphemic approach is a reasonable approach, but the limitations are that without enough data, it's going to make predictions based on the limited set of English rules it learned, and seemingly simple words become more complex when you break down the spelling that way. And so English really only has maybe 40 to 50 phonemes, or those important sounds, speech sounds that carry meaning to speech. But there are over 230 graphemic forms of those sounds, and that's where this complexity comes in. So to illustrate this, you can see just a Z sound can be represented, 7 different ways. Even worse, this A sound, I can't count off the top of my head how many different ways to represent the A sound. And even more confusing, some of the ways representing here, like AY, can be said A. We also see it down below in an E sound. And in other words, an I sound. So it's many to many. The spelling and the pronunciation relationship can go both ways, many to many. And that just adds to the complexity for a model to learn. I like giving this presentation live because I get to see some of this information click for folks, and I can, recognize when folks are saying, English was so hard for me to learn, and now I understand why. Even native speakers, just learning as a child how to spell and sound out pronunciation. I have a 3-year-old who's really curious about reading right now, and he gets really frustrated with me when I try to explain that a certain letter sometimes makes this sound and sometimes makes this sound, So it's a frustrating thing in language. So an alternative approach is the phonemic approach. we can transcribe this script data into the International Phonetic Alphabet, which Catherine was describing earlier, and I can't wait to hear more about how Oxford creates these transcriptions. But IPA is a really, really powerful tool, and a huge goal behind it is to disambiguate all of those spelling nonsense that historically have just created the English language. If we can remove that ambiguity for the model, then it can much more quickly align accurate sounds from the spectrogram to a character set that always represents that sound. It doesn't change based on context or word. You can see here the stress of the syllable within apple is also represented. So that first ah sound, we have a single P phoneme, not two. We have that sort of hidden vowel sound between the P and the L, and no silent characters represented. So this transcription will always read apple, always. You don't have to guess. And it really reduces how much data that the model might have to train on. It reduces yet again, the complexity of how it's learning those things. Yet there are still limitations here, of course. If any text provided to the model after the fact was never learned on or doesn't exist in a transcription dictionary, then the model's still going to have to make some ambiguous guessing. We can get into this a bit later, but there are certainly places where that might happen. My own name is spelled Rhyan. It doesn't exist in a transcription dictionary, to my knowledge, because my mom invented the spelling when we were in the hospital. And so you can take away the H and probably find it. But for this illustration, the model is going to have to guess again. It can't find a transcription. It doesn't know the IPA representation of this. It's back to sort of a graphemic guess. And so I think I'll pause there before we get into some of our features.
Yeah, I think this is a good time to ask Catherine if you could say a little bit more about Oxford Languages data. We obviously create transcriptions like this. So would you be able to tell us a little bit more about that data and why it's particularly helpful for cases like these?
Yeah. So I'm going to show a little further in about the detail of what the particular symbols that we use, particular implementation of the International Phonetic Alphabet that we use. But one of the things that I think we supply very usefully for this kind of use is exactly these gaps, places where it's not going to be. So I noticed there was a question in the Q&A about, well, how do you handle things that are not in a dictionary? I mean, the kind of answer is, well, we try and put them in our dictionary. So names, peoples and places. So broadening our coverage of what we might call encyclopedic content, things like names, places, companies, neologisms, having a really broad base for that inclusion and having, you know, your finger on the pulse of those changes that's part of what brings useful data. But also we have some other things that we cover, I think quite well as well. So our coverage of inflected forms is pretty broad. So we cover plurals and conjugated verbs and so forth. And that's again something that in a monolingual English dictionary, historically, you wouldn't necessarily put all, have the ing and the ed and the s and the different forms that you wouldn't necessarily create for all those, because they would be seen as somewhat predictable for a human native speaker user, not predictable for this kind of use necessarily. So having that wider coverage is helpful. Things like compounds. So although we talk about words in a dictionary, a lot of our head word forms are not single words. They're things like 2 or 3 word compounds, and aspects of the pronunciation. Having a better coverage of those things can give a much more natural outcome for a synthetic voice. I'm thinking particularly about things like, if you think about 2 word compounds on a shopping list, things like orange juice and icing sugar and baking powder. Often, if you were to build those from their 2 component parts, you might end up hearing something more like baking powder, orange juice. And so by having the word forms be sometimes bigger than words, that's another support. But the one that jumped out at me from looking at the slides is how we handle how we very carefully give supporting information around homograph heterophones, so things that are written the same but don't sound the same. Heteronyms, they're sometimes also called. So in Ryan's example, we had at the end of the synthetic speech, he said, I can't remember the number, but it was IN dot, and it was correctly rendered as inches. Now, IN dot could be the word in, it could be short for India in a country code, it could be lots of different things, and knowing which one it is from contextual information and having the coverage that, oh, well, if you have that, it might not be that, it might be something else. So that's not always initialisms or abbreviations. It might be things like different parts of speech. So where you've got contract and contract, or record and record, or words like SAKE in the context. Is that sake? Is it sake? Are we supplying all of the possible things that it might be to let at your end figure out which one it actually is likely to be in the context? So yeah, those are some of the, I hope those are some of the aspects of our data that can make this kind of application better and better.
Thanks, Catherine. I was just working today on the difference between Newark and Newark, depending on the city that it's referring to. So that's a new thing we now have in our database.
Anyway. We'll put Ryan in. After we finish this, we'll go put you in.
We'll add Ryan. Yeah, would you like to carry on, Ryan? Tell us a little bit more about your respelling system based on this unique approach.
And Catherine, that's a great segue, really, because after we looked at all of the approaches we could take with training a model, we were left wondering, well, what does the model do when it comes across a case that's even ambiguous for a human to learn? How will it know to make the best possible prediction? And there's just cases where it won't necessarily. It needs more guidance. I think given enough context within a sentence, it should be able to differentiate record from record or live from live. But there's cases where we have a customer, for example, that's an educational client, and they're teaching vocabulary. So part of the audio they're creating is a single word. It's not going to have any context. It's not going to have any context within a sentence to disambiguate. And so we wanted to be able to give a tool to our users who could directly tell the model, just like you would to a fellow actor, pronounce it this way. When you're reading this sentence, we want to emphasize this word. We want to choose this regional pronunciation because our audience is from this area, all of those kinds of things. If we just have a strictly graphemic or strictly phonemic approach, those guesses become really tricky. In a graphemic approach, users are encouraged to just spell it creatively. Try adding a few extra letters or change the spelling and see if it works. It can be a frustrating sort of guessing game. In a phonemic approach, generally speaking, the word either needs to exist in a transcribed dictionary so that you can give the IPA form directly, or the user needs to be well-versed in IPA themselves. And we just felt like that was probably not a fast enough or an approachable enough solution for most of our customers. So we created something right in between, our own respelling system that uses the 26 alphabetic characters found on the keyboard. You don't need an IPA keyboard, for example. You don't need to understand the reduced set of IPA symbols used in a particular dialect. You don't need to make any of those decisions. We just created it in a way that it has consonant coverage, vowel coverage, and you can specify the syllable emphasis. We separate syllables with a hyphen, and you capitalize the emphasized syllable and keep lowercase. We didn't even differentiate between like primary or secondary stress. We really tried to simplify it so that the model is still able to not only learn how those pronunciation cues will be, what is meant behind them, but it still leaves the model room to know, well, this is how this particular voice responds to these respellings, or this is how this particular person would probably pronounce these things given X rules. And so I want to just illustrate with a few audio examples again why this was important. This came from a friend of a friend, actually. This is how she spells her name. She's often heard it pronounced incorrectly. So we use this as an example. Borrowed city names. This is Spanish, of course, but people in America are going to say this with an American accent and they need the correct pronunciation. I like this one because we have a whole song about this, potato, potato, etc. So we'll hear how the model responds to just the word as given versus when it's given a respelling. And then the example we were just talking about, a single word, no context. How do I know which form is meant to be spoken? So I'm going to start at the top. Let's listen to some audio. This will be the text on the left, no respelling provided.
My name is Malika, and I'm happy to be assisting you today.
That's not actually how her name should be pronounced. And so with our tool, very simply, you can type exactly the consonant, vowel, and syllable that you expect, and we can get her name pronounced correctly. Let's hear it.
My name is Malika, and I'm happy to be assisting you today.
I'll just run through the next few without any explanation because I think we can differentiate ourselves, but I'll start on the left and then play the form on the right.
Let's go to La Jolla, California.
Oh.
Let's go to La Jolla, California.
I say tomato, you say tomato. I say tomato, you say tomato.
And last but not least,
record, record.
So very quickly, our users can actually type it themselves and just say, this is the pronunciation that I want and need. We find it to be a really powerful tool that constantly is getting better. This really brings us to our partnership with Oxford because our prototype for this that we developed a couple of years ago proved that a text-to-speech model can in fact learn graphemic, phonemic, and this respelling form so that our users can wield it. But the dictionary, the pronunciation dictionary we were relying on wasn't being maintained. It was built maybe 15 or 20 years ago. It was very limited. And so we needed a source that we could trust that covered hundreds of thousands of pronunciations. And yeah, it was just highly, highly accurate so that we could continue to expand this feature and make sure it works as consistently as possible for our users.
Thanks so much, Ryan. That was fascinating and really cool to see how it all works in action. So, Catherine, would you now be able to tell us a little bit more about that source, about our big database, and how we kind of manage and specify our pronunciations?
Yeah.
And would you like me to present or
yes, if you can. Could you put the first of the two? I have just a couple of slides just to illustrate what we have here. So this is before I go through the points in the slide, I'll just talk about IPA for a minute. So IPA transcriptions, we offer them in what we call a super specified version, which sounds a little bit complicated, but just to unpack it slightly, our different dictionaries, even within the dictionaries that Oxford University Press produce, have certain historical differences in how the specific IPA models that are chosen. And so that was one of the drivers for saying, what about if we used IPA transcriptions that are super specified, that have all of the possible things that a transcription might want, and then from that super specified version, which is what we store centrally, which is kind of the point of truth for all of the pronunciations, we can then generate the pronunciations that are wanted for different products. So some products might want to have syllable breaks and some might not. Some products might want a particular symbol for a particular sound and others might make a different choice. So by having the specified, the super specified version as the parent, we can have all these different offspring versions of the transcription that can be used in different dictionaries, but also in other applications that are not dictionaries. And one of the offspring of our IPA transcription is a respell, which is very much very similar in form to the respell that Ryan's just been demonstrating. We've just within the last year or so, we started to offer that on our on the OED itself. If you look at a word in OED.com, you'll see IPA, of course, but also the simple text respell underneath. So just jump back to the first slide, and I will say a bit more about what the data consists of. So we've got over 1 million, about 1.1 million and counting, super specified transcriptions of English word forms, and from that we're deriving all of the transcriptions that any product or any licensee require. And linked to each of those transcriptions is human voice audio, which we make the old-fashioned way with people talking in a booth. We record that and then we link those up, and that's made available as on our products and in our data sets. The point that I've already touched on is that it's all curated editorially, just to keep that consistency going, keep the coverage growing, and expand, not just expand in a kind of willy-nilly way, but expand in the directions that we learn are the best places to direct our attention and our focus. One of those expansions in recent years has been covering our localization coverage. So beyond British and US English, we've got large representation already of Australian and Indian English, and lots of other smaller World English sets, and potentially in the future, looking beyond English as well. But that's more for the future thoughts. Let me see the second slide. I've got just a couple more things to point out. So yes, here I've got the example that of what we mean by super specified IPA. That helps us to build data sets which are tailored specifically for the products with a preferred style. So I don't know how easy it is to see the small differences in the transcription there, but so that's the US word better, and the transcription you see on the left before the arrow is our parent transcription. So we use the S is a cardinal vowel 3 for the E vowel. We use the flap, the kind of R without a stalk, for the flapped better, and the R, the post-vocalic R, is represented with our full R symbol. Now, the different varieties that you've got presented. So we've got the first one, that flap T is being represented with a D instead. That's how OED chooses to do it. We can represent it with a T with a little voicing diacritic underneath. That's how another OUP product presents it. Some people prefer a different symbol for the first vowel, so you can see the regular typed looking E rather than the script one, the Greek looking one. And then the same thing again with the D symbol. Then the last one is something where rather than having schwa and then R, it's a schwar. Forgive me, I don't have a post-vocalic R, but yeah, that's the R colouring on the schwa is presented as an alternative. And I say with or without syllable breaks, with or without those kind of conversions. So we can be very pragmatic, agnostic about, we're not saying this is the one true way you should use IPA symbols to transcribe stuff. We can be very much, have it how you like. If you want to replace that with, a completely new symbol or something that fits your use case, then we can furnish you with that, because we've got the parent form to generate it from. And as I say, one of the things we can generate is the simple text respell that we're using in our own products now as well as things that are in an IPA system. So, and as Ryan said, there are use cases like teleprompters or things delivered via SMS or just settings where complex symbology isn't not what anybody wants. Lots of places where that's just what you need.
Thank you so much. Oh, hang on, I'm in charge, aren't I? There we go. So we've only got about 15 minutes left of the webinar, and I definitely want to make sure we have time for some questions. We've got lots of questions in the Q&A, so thank you, everyone. Please do keep asking questions if you have any more. I've just got one more question that I'd like to ask Ryan before we move on to the Q&A, and that's about the transcriptions and the audio. So obviously they're both types of pronunciation data, but they can support the text-to-speech model in different ways, presumably. Can you tell us a little bit more about how that works with WellSaid Labs?
Yes, definitely. I've been kind of breaking it down into 3 components that our model and our tools really benefit from with all of the data that Oxford has given us. So the transcriptions, I think we just talked more specifically about, because those inform our respelling rules specifically. It informs how the model will learn and then later respond to pronunciation cues written in the format that we've built. Audio, hugely important. We don't always know which form an actor chose to pronounce something with, for example. So knowing that we're getting audio files that were crafted specifically from one particular pronunciation of a word, that helps the model just learn pronunciation across the board. It's many, many more words than we could have covered in standalone script data or just with our voice actors reading everything in context. So it really expands the vocabulary and just the representation of all of these graphemic forms and sounds and words that it hadn't learned before. So that's huge. And the third thing we just launched recently is a pronunciation suggestion tool in our studio. So now users can actually go to a word, maybe it is a medical term that's difficult to pronounce, or a word like record or record where they want to disambiguate the pronunciation. They can go to a drop down in our tool, and all of the pronunciations are populated there for a given word, and that includes regional preferences for those words as well. And so it gets, we rely on Oxford's transcriptions again to inform what the respelled form of the word is, and then that gets offered to our users directly. Yeah, I think those are really the 3 highlights from all of the data that we get from you all.
Brilliant, thank you so much. So I think we can move on now to the Q&A. We've got about 12 minutes left. So we've got lots of questions in the chat there. And also we had some questions submitted in advance, as anyone who registered will know. So we're not going to have time to get to everything, but I will just pick a couple of questions that I think might be particularly interesting to discuss. And we'll go from there. So the first question that we had submitted to us was about looking forward, kind of how are both Oxford Languages and WellSaid Labs looking to evolve in the future and evolve together? So if Ryan, would you be able to start? Tell us what you think.
Yeah, sure. I think certainly adding more and more words like we were talking about is huge, and expanding into these other dialects is also really important. For pronunciation data and just learning, we have avatars that speak several different English dialects, but knowing that the pronunciation they're learning from is really accurate, that's huge that we get that from the audio data. The respelling system, that's interesting. We're diving into now recognizing, is our respelling system dialect or accent agnostic? Does the symbology cover just what's important to a language, or do we need to be more fine-tuned there? And do we need to tie it to a UK specific set of symbology or an Australian set of symbology, et cetera? So I think that's some of the interesting work that's ahead of us. We're also looking at how do we expand these features into other languages completely. We have a few languages in the works, and we want to make sure that they have access to the same neat features that the rest of our TTS does.
Brilliant, thanks. Catherine.
Yeah, so expanding the coverage is really what it's about. World English, wider ranges of Englishes from different parts of the globe, more regionalisation within the countries that we're covering as well. So that's including within the UK and the United States. And starting to research the varieties really in depth, but thinking about it from the text-to-speech, from the AI space, which so when we're thinking about a World English, our approach starts from the words and the language that are actually used there, and we're trying to build really accurate pronunciations that are very faithful to the varieties, but also usable at the end. So it's always quite a balancing act between very, very micro accuracy and something that's functional and something that can describe a variety as a larger chunk, and just shaping how, thinking about it from the perspective of what's useful in a dictionary setting and what's useful in a data set, and for these different applications. It's actually not as different as you might think. It's not. I don't feel pulled in different directions by those requirements. Actually, a lot of the time, the one supports the other, and that's something that's really rewarding. And yes, expansion beyond English. We played around a couple of years. Well, played around. We did some very serious tests, but we looked at our own simple text respell a couple of years back, looking at how we might use it for French and for German. Spanish, you see, there are languages where, as you will know, and as people listening to this will realize, but I think it's worth calling out, that there are, of course, languages that don't require respellings and pronunciation guides. There are languages where the written form is tells you exactly how it should be pronounced, tells you where the stress will fall. Is, there's a completely one-to-one relationship between the writing and the sound. So this isn't required for Korean or Polish, or but there are many languages besides English that it certainly would be required for. And so yeah, starting to explore those is definitely something on as part of our mission as well.
Brilliant, thank you. Very briefly, we have a question, I think probably more so for WellSaid Labs, which is, what prompted this collaboration?
Yeah, I think our need for trusting really highly accurate data, and lots of it. Did a bit of research into some other dictionaries that might be available to us, and Oxford just had the bulk and also the flexibility to work together and say, we need, as Catherine was describing, like, we can actually go back and forth and say, we really need this variety, or we need this amount of information around these words. I think that was really important. I mentioned earlier, we had a prototype. We knew this concept could work. It was, to our knowledge, the only text-to-speech service that can offer this type of tool. So how do we go make it as consistent and robust as possible? And that all led to just partnering with Oxford for the highly accurate and curated data.
Brilliant, thank you. I'm just looking at the Q&A questions we have here, and I think we've got a few that are kind of similar, and also similar to a question that we were asked in advance as well. So I'll just max this one here. A few people have asked about sort of, this is a question for Ryan and WellSaid, but a few people have asked about things that aren't necessarily captured in a phonetic or phonemic transcription. So we also had a question in advance, which was, intonation and tone of voice often characterize speech. Are these characteristics part of any AI text-to-speech models? And then we have this question here, which is about intonation, and how we noticed, I could hear in your example that you gave, there were clear like intonational cues. So how that's kind of created in a text-to-speech model. And we also have another question here, which just came through, which is, how would you handle onomatopoeic words or sounds that are not necessarily words, such as gulps and breaths, etc. So I think all those questions are quite similar, and they're more about what's happening beyond the phonetic transcription in an AI text-to-speech model. Thanks for that.
And Jeremy, this is great, because I think you're spot on. Punctuation is kind of the starting point for sure. It's the most obvious. Most people know that if you see a comma or a period, you're going to pause, possibly take a breath. If you see a question mark, there might be a rise in your inflection somewhere within the phrase. But even that becomes really complex and really interesting. There is certainly an understanding within the model. There's a layer all around just context, grammatical structure, the content of what's being spoken. So a lot of that goes into it. We're working on how do we expand that capability into even more emotional awareness, perhaps, or tone awareness for just the maybe the somber or the excited nature of the content itself. That part gets really interesting, because it all relies on how the training data is annotated from the start. But if we are thinking of just intonation and punctuation even, I've used this example in the past, because we do have a lot of customers that will say, I added a question mark, it didn't go up at the end. And it's easy to kind of jump to, if you see a question mark, the tone of voice should rise at the end to ask a question. And it's simply not as it's not as simple as that. And the example I've given is the same exact string of text that might say, "Are you going to the bank today?" If I just change where the upward inflection lands within that phrase, I could be implying a completely different question, right? So, are you going to the bank today? Could imply that somebody else is going. Are you going to the bank today? Could imply you're going on a different day. And so there's a lot of other things, even outside of text, that aren't immediately obvious because it's the exact same words or the exact same punctuation that's in there. So the other thing WellSaid is working hard at doing is more tools. We launched our cues last year, which allow folks to actually tag different parts of that speech to say, I want to emphasize here. I want to speak this part louder or faster. And there's more we want to do beyond that that goes into these intonation choices. It's not just how can the model predict it well, but how can users shape it if they need to.
That's fascinating. Thank you.
I thought of a little thing to add there, which is on the on Anton's question about the words that are not necessarily words. One thing that we allow ourselves in our own data is where a word is an interjection. We break from our usual rules about we can only use these symbols in this way, and we allow ourselves to use it. We're still using IPA, it's still IPA transcriptions. But for instance, if someone wants to transcribe brr or shh, we use length to indicate that there's length on those particular sounds, and so we're able to have. It's probably quite small. If you filter for it, it'll probably only be like a few hundred things, but yeah, some slightly closer to the phonetic reality. Because if you just followed the rules, you'd end up just having something like burr or sh, and it wouldn't be the meaning, wouldn't carry the meaning you wanted to convey. So yeah, we start to think about that. There are not that many words like that in traditional dictionary settings, but they do still crop up.
Yeah, thank you. We've only got a couple of minutes left, and I know there's a lot of questions here that we're not going to have time to answer, so I apologise for that. But there's just one more question that I'd really like to ask, because it's not really on the subject of text-to-speech, but I think it's a really nice question to end on. Which is what can local regions and communities do to help capture and protect their dialect or accent? I don't know if Catherine, would you like to speak?
Yeah, I mean, I think that one thing that's really nice to see is as tools like these become more diverse, they become more recognizing of that difference and that range. And I love the idea of being allowed to sort of tailor something by accent. But yeah, I mean, to protect your dialect, your accent, your own particular variety of English, use it yourself, signal boost it, make sure it's being celebrated, make sure that if there's anywhere in your community or your educational system that it's being not celebrated, it's being suppressed or it's being shamed, combat that, fight that. And when codifying authorities like dictionary writers are not capturing it, tell them about it and encourage them to do better. We as lexicographers, we want to describe language the way it is, and that's as meaningful for for all the different things that we end up using our data for. So if we're not capturing changes that are there, then tell us about them, because we want to hear about them and we want to include them. So yeah, I don't know, Ryan, do you want to...
I don't know if I have much more to add. I think that's spot on. Mm-hmm.
Great, thank you so much. I think it's 5 o'clock now, so we're at time. So I'll just say thank you, everyone, for joining us today, and for those of you who stayed up to the end, thank you so much. I really hope that this webinar was valuable to you. I really enjoyed this discussion. It was really interesting to hear about, especially Ryan's perspective. And thank you so much to Ryan and Catherine for joining us today. If you're worried that you missed something during the webinar, or you want to just watch again, catch up again, you will receive a link to this webinar in, I think, around 2 weeks' time. So thank you so much to everyone who participated today, and goodbye.
Yep. Look forward to continuing to work together. Thank you.
Yes, I agree. Thanks for having me. Thank you all.